Hello and welcome everyone. We are so excited and glad to have you join us virtually for this build session on how to explain text models with InterpretML. My name is Marnush Simicki and I'll be the moderator for this session. I'd like to highlight that there is a dedicated area for you to ask your questions. We would love you to do that because that makes our session a lot more interactive. I'll bring a bunch of questions to the presenter to address in the QA section towards the later part of this presentation. Without further ado, let me introduce Minsu Thigpen to drive us through the content. Minsu, the floor is all yours.
Thanks, Marnush. Hi, everyone, and thank you for attending our session. My name is Minsu, and I'm a PM on the Azure ML Responsible AI team. We're super excited to share with you InterpretText, InterpretML's new offering for explaining models with text data. In this live session, I'll be giving a brief overview of our new explainers, along with a quick demo. So I'll be giving a short introduction of how we came to create InterpretText, as well as providing a motivating example from real life. Then I'll give a brief overview of the general NLP pipeline that we're talking about before diving into our explainers and how it fits into everything. Then I'll be walking you through a demo notebook, and you'll be seeing these explainers at work. And then I'll go straight into opening up the floor for Q&A. So please feel free to post your questions on the chat, as Marnush said before, and we'll try to answer them in the end. So if you've seen the Responsible ML live session before this one, on getting started with understanding your model, you'll recognize InterpretML as an independent org that houses multiple interpretability techniques. Though much of the functionality for InterpretML is for tabular data, we've gotten many requests to extend this support for text data. We currently only support topic classification, but are looking forward to growing our repo to include more NLP scenarios. And we obviously welcome your contributions. If there's an NLP scenario that you want to see supported, please let us know in the chat. So InterpretText comes with explainers that support BERT and RNNs, as well as standard scikit-learn models. With our open source toolkit, users will be able to take advantage of the state-of-the-art interpretability techniques with a common API across integrated libraries, as well as its own visualization dashboard for understanding which key phrases and words were important to your text classification. So let's consider a real-world example where you might actually need to use this. Let's say you're a candidate applying for a job, and a hiring manager is going to use a machine learning model or an algorithm to categorize the free-form text that you're putting into your application, maybe into distinct buckets or categories that they care about, and raise red flags if your submission falls into a certain category. So in a high-risk situation like this, where obviously your opportunity for a job is on the line, it's very important for hiring managers to be able to understand what the algorithm is doing when raising these red flags, such as needing to know which key phrases or words that it used in order to make that assessment. So let's take a step back. Generally speaking, there's two broad classes of NLP approaches. There's classical ML technique and deep learning. In classical techniques, the first step is pre-processing. As you can see in the first box, it involves steps such as tokenization, normalization, noise removal. Then that processed data is fed into the model. We support models such as linear regression, light GBM, or random forest. The output depends on the scenario you're modeling for. In our case, text classification. For some of these approaches, the internal functionality is very well understood, and as a result, the user is confident in the explanations provided. However, these methods, although widely adopted and easy to use, are pretty limited in their accuracies on real data, real-world data sets. So then comes deep learning, right? So recent advancements in NLP owe much to this, such as deep neural networks such as BERT. These models have really high accuracy on NLP tasks. However, the trade-off is that they're black box models, and their decisions are thus difficult to understand. And when we say black box model, we mean you can't really see what the inner workings of your algorithm is. The research community has created a suite of state-of-the-art interpretable models, ranging from post-hoc analysis to plugins during training. Though promising, these methods are kind of hard to implement in practice and not accessible to everyone, like data scientists. Therefore, to make these recent research developments more accessible for data scientists, in this toolkit, we've released open source implementations of 3 explainers. The first, 1 classical and 2 state-of-the-art that provide local explanations on text documents. So the first that we'll go through is the classical text explainer, which is a standard set of glass box models. And then the second is the unified information explainer, which is a post hoc method and model agnostic. And the last one is the introspective rationale explainer, which is a plugin method and also model agnostic. Next, I'll talk briefly about these models in order to give you a more good sense or understanding of what they actually do. So the classical text explainer is implemented as a wrapper around the entire NLP pipeline. So you can kind of think of it as including all of the text pre-processing, encoding, training, etc. Obviously, you can support and you can supply your own data set without any external procedures, and it's compatible with linear models with support for coefficient and tree-based models. This API is modular, and users can swap out nearly all the components. The default configuration we have for users to use is a 1 gram bag of words for scikit-learn. The repo, as you see on the bottom of each slide, has a sample notebook illustrating how you can use this API for multi-label text classification scenario. We'll also be seeing this notebook during our demo. The Unified Information Explainer is a state-of-the-art NLP interpretability model and was developed by researchers from MSR Asia. The paper was presented at ICML in 2019, so pretty recently, last year. This explainer is post hoc, meaning that it needs a previously trained or fine-tuned DNN model. It's model agnostic, as long as it's a DNN. So it works for BERT, RNN, CNN, LSTMs. However, we've only implemented support right at the moment for explaining BERT, and we want to extend it to other DNNs in our future work as well. It's a mutual information-based approach, and it provides the importances of words as it goes through all the layers of the neural network. Since each layer is explained, the explanations are unified and coherent, thus the name. I'd like to provide a quick intuition on how this method works, but for more details, please see the paper, the name of it, and a link to it is at the bottom of this slide. So the key task here is to associate latent representations of the word with interpretable units in the hidden states of the layers. We want to quantify how much information of an input word is included in each layer. So a very important word, for example, will have a lot of information encoded. There are 2 forces at work here that you can see in the diagram. As the word embedding is going through the layers of the DNN, it is perturbed, and we're trying to add as much noise as possible. What we want to see is how much the output changes as the noise is added. So if a lot of noise affects the output, then it is an important word for that layer. If it doesn't affect the word, then it's not that important. On the other hand, the loss function tries to minimize the difference between the perturbed hidden states and the original hidden states, since obviously we don't want to end up explaining a completely different model by perturbing it too much. These 2 functions work hand in hand to help us better understand how the words are being propagated through the layers of the neural network. And there's also a sample notebook for this as well in the repo. So our last explainer is the introspective rationale explainer. And this is our other state-of-the-art explainer. It was developed by researchers in the MIT Computer Science and AI Lab and was presented at EMNLP last November, so also pretty recently. More details about this method are in the paper, but here's a brief intuition. This method introduces a plugin into the training process and makes the black box model more interpretable. This plugin is called the introspective generator, and you can see it delineated by a dotted box in the diagram to the left. This introspective generator splits the text into rationales and anti-rationales, which are denoted as R and R superscript C. The rationales are a subset of the words that, according to the introspective generator, are important. On the other hand, the anti-rationales are not important, according to the introspective generator. The introspective generator simultaneously trains the model on both of these. It tries to maximize the accuracy of the model when only using the rationales, and conversely minimizes the accuracy when using anti-rationales. Since the model only sees the rationales at training time to make a prediction, strong guarantees are provided about which phrases matter to the prediction. Generally, no other method provides such strong guarantees. So now that we've gotten through a brief overview of the three explanations, I'd like to take a moment to look over this table, which is also in our repo README, and kind of explain and walk you through what are the different scenarios in which you would be using these explanations or explainers. So we recommend using the classical text explainer when using a more classical ML approach to NLP. And if you don't want to deal with the NLP pipeline, we offer that for you as well. However, when needing to understand a neural network at a layer-wise level, we highly recommend the Unified Information Explainer. And then if, let's say you, for instance, have an RNN or a combination of BERT and RNN, we recommend using the Introspective Rational Explainer.
Awesome. Thank you, Minsu. Let's answer some questions. So the Unified Information Explainer and Introspective Rational Explainer seem very similar. So if Introspective Rational Explainer is also supporting BERT and RNN models, can you explain a little bit then what is the point of Unified Information Explainer?
Yes, so in many instances, you actually want to see at which layer the features are kind of having the most important values for. And so to understand sort of at a layer-wise level, you're going to really want to use a Unified Information Explainer as opposed to the Introspective Rational Explainer.
Awesome. Another question is, what if someone uses a brand new featurizer? I know you mentioned 1 gram, but can we bring another different featurizer?
Absolutely. So the classical text explainer is highly modular, and we really encourage people to swap out whatever parts they want to bring to the table and leverage whatever we built when they don't want to do the work of building it. So they can for sure bring their own featurizer and swap it in.
Awesome. And last question, if I have an existing PyTorch architecture, can I explain that too?
Yes. So as you can see in this table, for the Unified Information Explainer and the Introspective Rational Explainer, we do provide input model support for PyTorch.
Awesome. Thank you.
Yeah. So we'll take a little bit more of the questions later, but now let's just go ahead and switch over to the demo notebook to take a look at the classical text explainer as well as the introspective rational explainer. All right. So as you can see, I am, projecting this from an Azure VM notebook, and so you can pip install whatever the package that we have, the interpret text. You can set it up in your environment. You can also just pip install with import sys in your Jupyter notebook, but you can definitely run this on an Azure VM. So these two notebooks are, as I mentioned earlier, available on the README, the repo under sample notebooks. So you can go to InterpretML / interpret text and be able to navigate to the sample notebooks to see these. And so here we showcase how to use interpret text for the classical text explainer. We sort of, although we're using logistic regression and 1 gram bag of words here, you can obviously bring in whatever featurizer as we discussed with Marnoush. We also leverage a lot of functionality from Scikit and Spacey. So, we really want our tools to be interoperable and play nice with all the other tools and popular tools that you guys are already using. So you can configure your parameters and load up your data. And then you can instantiate your explainer by sort of calling this API call to create your explainer. And so you can see that you'll be able to see that this is a similar pattern for the introspective rationale explainer as well. So once you have your explainer, then you just go ahead and do the standard split your data into training, test, and then you want to load up the classifier that you care about and then be able to fit and test your models. So we also provide some functionalities for you to just do a quick sanity check with performance, model performance metrics that you can just run. And so we see that this is the best classifier. Here are the performance metrics. And now we sort of come to local importances. What that means is for the text document that we've put in here, we want to see, okay, for this document, what are the specific keywords that really contribute towards this prediction. And in this sample notebook specifically, we're using the MNLI dataset, and we are kind of categorizing different text documents according to genres such as fiction, as we see here, or government documents, or it's a multi-text classification scenario. So as you can see here, you just create your explanation dashboard that we have custom designed for using our explainers for, pass in the local explanation, which you've already loaded up your document with. And in here, we loaded up the document. I traveled to the beach, I took the train, I saw fairies, dragons, and elves, and we see that this was predicted as fiction. There's a slider bar here to sort of navigate up and down to see top K most important words that contributed towards this, as well as being able to toggle, okay, I only want to see the features that positively contributed towards this prediction or negatively contributed away from this prediction. And also one other thing is that you're able to see what are the feature importance values along with a localized a string that will show you where in the text this actually is. So we see that we have, the in front of train and a, period after train. And so we also see this correlates to the text box at the bottom, which has a highlight if it's a positive feature importance and an underline if it's a negative feature importance. So we'll see that this user experience of the visualization dashboard doesn't change according to the explanation that you're or explainer that you're using. And so now I'll hop over to the introspective rationale explainer. We're using the Stanford Sentiment Tree Bank data set, which we're using documents that basically are movie reviews, and we're going to do a sentiment prediction of whether or not that movie review is bad or good as 0 and 1. And so you go ahead and import your explainer. And in this sample notebook, which you can find online, we direct you towards, the 3-player explainer model that we sort of base this off of, as well as the SST2 data set. And you can also see what data set we use where it's linked here. So we go ahead and set up our parameters. We want to, set up the training procedure parameters, model configurations, determine if your model type is an RNN, if it's not an RNN, and then we load up the data set and we're able to do the tokenization and embedding. So depending on whether or not you have an RNN or a BERT, we sort of give you the preferred encoder for both of those. Then we can go ahead and go through the process of instantiating an explainer, which, as we saw before in the other notebook, is a pretty similar API call, where in this case, we have to make sure to pass in the model type, so whether or not it's an RNN or a BERT, and CUDA. And then we set up the preprocessor and basically give it all the model configurations and parameters that we set, and then we fit and train it. So we trained it for 100 epochs, and we stopped at 20%. And we're able to see, model performance metrics as well, such as test sparsity and accuracy. And then again, we see the local importances for these different text sentences that you can pass in. So we have sentences like beautiful movie, really good, the popcorn was bad, and the premise is in extremely bad taste. Etc. And so we'll see that these have been sort of predicted as 0 or 1. And we also see the local importance values as they appear as numerical values. But obviously, these are not so helpful to us and our human eye. So passing these in as well to the visualization dashboard will give us the same visualization dashboard that will let us interpret what's going on with these local feature importances. So we see here that the top 3 features that are going to positively affect the prediction of 0, which is a bad movie review, is the word bad, which is, that's pretty good sign of whether or not the movie is bad, and then the premise and extremely. And as you can see here, we have these tokens U and K for words that are not previously included in the training set. And we only have the positive feature importances in this case for the rational explainer because that is the way that the introspective rational explainer is set up to only have your rationales that you've trained on and gotten the accuracy, maximize the accuracy for. Great. So going back to the presentation, yeah. So, thank you so much for joining us, and we really, really welcome contributions. We're an open source toolkit, and if you have any questions or thoughts, please reach out. The repo link is right here, along with some other responsible ML resources and more information about InterpretML, which InterpretText is a repo under. And so without further ado, I'd like to open up the floor for questions from the audience.
Awesome. Thank you very much, Mirsu, for a very insightful presentation. The very first question is about InterpretML. A lot of people actually have seen that in the previous presentation by Sarah BERT. So the question is how InterpretML and InterpretText differ.
Yeah, so as I said in the very beginning, the reason we came up with a whole different set of explainers under InterpretText for text data is because the sample space for text data is really, really big. And not all words appear in all contexts, right? So even the input space behaves very differently and has different requirements than numerical data or categorical data. Also, there's a far more complex web of feature interconnectedness, i.e. grammar rules that you can't just break and just take words out, because that might just ruin the meaning or the sentiment of the whole entire thing. And additionally, visualizing text data as opposed to numerical data and their importance values is very different from just tabular data. And so it required a different dashboard than the one we designed for tabular data under Interpret.
Perfect. Makes a lot of sense. Now, speaking of different types of data, do you have any plans to expand this repo to include computer vision scenarios as well?
Yes, so we hope to bring to open source the rich research that is already happening in interpretability for computer vision. There's a lot of work happening in interpreting image data, and by bringing it under the roof of our interpretability toolkit with InterpretML, we want to create an ecosystem around interpreting image, tabular, text data, and have it interoperable with other interpretability tools in the open source community.
Awesome. Now, another audience question: can we provide PyTorch or TensorFlow DNN BERT models, or whether it supports a specific library?
At the moment, we support PyTorch, but yes, so yeah.
So I assume that it's a community driven, so you're more than welcome to come and expand it.
Yes, absolutely.
Awesome. The other question is, can you walk us a little bit through the research behind this? I know you listed some papers, and I guess the audience will be interested to hear how sort of this collaboration between us and research teams happened.
Yes, so for those of you who wouldn't know, Microsoft has its own research community and organization called MSR. And so that's what I was referring to with the Unified Information Explainer. The paper came from MSR in Asia, I believe in Beijing. And we kind of keep an eye out for all the major NLP conferences, EMNLP, oh man, that one's always hard to say, is one, and also as well as, and that's sort of where the paper from MSR Asia came for. And then the introspective rationale came from MIT. And we also saw their paper presented at a major conference. And also, sorry, let me take that back. The MSR Asia paper was shown at ICML, not EMNLP.
Awesome. And the other question is, basically, you walked us a little bit through an HR scenario. I think it's going to be very insightful if you share one real-world scenarios where this interpret text was sort of used and tested, and whether you can share some insights about that.
Yeah, so that's a really great question. While we were creating this, we definitely wanted to take advantage of different customers who had interpretability needs and sort of ran this toolkit with them and kind of got insights from what their needs are around this space. And a pretty common use case that we found was basically triaging customer feedback. People want to automatically create tickets, right? They're receiving like hundreds and hundreds and thousands of customer feedback things via email or whatever tool every day. And so they wanted to know if a customer, if a certain customer feedback warranted a ticket being generated, or if it was something that was just like, oh, I love this feature, great job, in which you wouldn't have, there was no action taken, right? And so take that one step further, and then they might want to classify what kind of issue this ticket might be addressing so that it can be assigned to an appropriate engineering team to kind of get on that and be able to, solve whatever case that is.
Sounds really great. And then there's an audience question. Emmanuel is asking, I have a use case of basically classifying a comment is truthful or not. If it was made by a bot or a real human, can this toolkit help me to basically understand how the model has made its predictions?
Could you repeat that question?
Yeah,
made by a...
So they do have a text classification scenario of basically whether a comment is truthful or not, or whether it was made by a bot or a real human. So they're wondering if they can state the toolkit can support that.
Yeah, absolutely. Actually, that's the scenario that we would probably be able to support. Text classification, you would basically have your training and test set and be able to kind of with, let's say you have a statement that's made by a bot versus a statement that's made by a human. And for, in the visualization dashboard, as well as the explainer, you'd be able to generate local explanations for those sentences and compare them and see, okay, I see a trend of, if a bot has like a misspelling of this or a grammatic, like a different grammatical way of using this word, then we can see that that's one of the features that go towards predicting this as a bot versus a human. So yeah, actually, I would love to hear more about that use case.
Okay, that sounds awesome. So let me check if we have any other question. Okay, so is the explanation dashboard also available on UI, since we would be able to talk about, like, basically, how can they use it? Can they host it somewhere? How can they access the visualization dashboard that you demonstrated?
As in, like, would they be able to build an app and then call the visualization dashboard?
Can they host it somewhere else, for instance? Can they host it and share it with other stakeholders?
Yes, yeah. So at the moment, we only offer the visualization dashboard as kind of with a widget within the Jupyter Notebook, but we definitely want to make sure that moving forward, we have interpretability, which is already incorporated into Azure ML, and we want to make sure that in the future, the interpret text joins that party as well. So yeah, you would be able to create a workspace and share that and be able to call it wherever you need it.
Awesome. Thank you so much. There are no more questions. Please feel free to close the session.
Great. So thank you again for attending this deep dive on our new addition to Interpretability Toolkit. And we look forward to growing this community with you. And if you haven't attended any of the other Responsible ML session, I highly recommend that you go check them out to get a broader overview of the other exciting work that we're doing. And you can leverage to better understand your models and build responsibly. So thank you so much.